Hi dear students, this is your second session of the physics bridge course. Today we are going to discuss about some new concept, that is one-dimensional motion. This topic is very familiar to you because some of these concepts that you have already learnt in your 9th and 10th standards. We are here only going to brush up about those concepts. Before going to the one-dimensional motion, it is necessary to know what is meant by mechanics, because this one-dimensional motion comes under the branch of physics that is called mechanics. Here the word mechanics, which sounds like a machine. The word machine we are already familiar. In our daily life we are using a lot of machines. Some of the machines which are moving during its working, and some of the machines which are not moving during its working. For example, if you are considering the car is one kind of the machine that is works when it is moves, or it moves when it is during its working. So next, second one is washing machine. This is the one kind of machine we are daily using it. So washing machine is one kind of the machine that is not moving during its working. So therefore the mechanics is the branch of physics, so in which we can study the particles or the bodies or the objects that are at rest or in motion. Therefore we can define what is mechanics. It is the branch of physics which deals with the study of particles or bodies or objects at rest or in motion. For example, in our daily life we can see some of the objects which are not moving. For example, if you keep some books in a sedge or in a rack, so it will not move from one place to another place until you are touching it, or until you are not moving it from one place to another place. So some of the objects we are seeing, that is birds which are flying in the sky, that is moving from one place to another place. So, and if you are considering the cricket ball, that is also moving from one place to another place. So if you are considering some more example, there is a fan. That is one extraordinary case here. The fan is not moving from one place to another place, but it will rotate at the same place. So from these three examples we can see that there are different types of the motion. So the different types of the motion also we can study under the branch of mechanics. Okay, therefore the mechanics tells the mechanics is the branch which deals with the different types of the motion along with the cause of the motion. What is the cause? So usually when we need to move some object from one place to another place, we have to apply force on it. So therefore force is the cause of motion. So how the force is acting on the body, that is also we can study under the branch of mechanics. Therefore, what is mechanics? Mechanics is a branch of physics which deals with the whole study. Means it may be the cause and it may be the types of motion. Okay, so it deals with the study of particle or the body or the objects that are at rest or in motion. If we are considering this definition here, we are observing that what is meant by particle here, bodies here and objects. Okay, therefore we need to define what are particles or bodies or objects, because when we are going to the science subject, we need to know what is the definition of each and every subject. We have to know what is the meaning of each and every concepts. Okay, so now we can move to the next definition, that is what is meant by particles or bodies or objects. The particles or the bodies or the objects are nothing but these are the quantity of a matter that will occupy certain position in the space, need not be any specified shape. Suppose if I consider this pen, so I place this pen here, so at the same time I cannot occupy the same position with another pen. Okay, what I mean you understood, right? So ಇಲ್ಲಿ ನಾನು ಒಂದು ಪೆನ್ ಇಟ್ಟಿದ್ದೇನೆ, ಸೊ ಇದೇ ಟೈಮಲ್ಲಿ ಇದೇ ಪ್ಲೇಸಲ್ಲಿ ಮತ್ತೊಂದು ಪೆನ್ನನ್ನು ನಾನು ರಿಪ್ಲೇಸ್ ಮಾಡಲಿಕ್ಕೆ ಆಗೋಲ್ಲ ಸೇಮ್ ಟೈಮಲ್ಲಿ. ಸೊ ಒನ್ ಆಬ್ಜೆಕ್ಟ್ ಹ್ಯಾಸ್ ಒನ್ ಪೊಸಿಷನ್ ಆ್ಯಂಡ್ at the same time we can't able to replace this position by the another object. So we can define the particle or the body or the object like this: a particle or bodies or objects are the quantity of matter that need not have specified shape but occupying certain position in the space. Okay, now if we are coming back to the definition of mechanics, that is, it is the branch of physics which deals with the study of particles or the bodies or the object that is at rest or in motion. So here half of the part is we already defined now. Study of particle or the bodies or object, what is meant by that we understood by this definition. Now we have to define what is meant by rest and what is motion. Rest or motion of object. Usually if we ask what is rest and what is motion, physically you know that. So when the body is not moving, that is called rest. When the body is moving, that is called motion. So in science, if we are telling like this, it is not enough. because we have to define it perfectly so that there is no confusion in the statement. Okay, so before going to the definition of rest or motion of the object, it is necessary to know on which factor this rest and motion is depends. For example, we can consider the motion of the train or motion of the car. Suppose here there is one car, inside one driver and one passenger is there. Okay, suppose you are standing beside the road, nearby there is one tree. Okay, so if these passengers, when they are passing from this position, you are starting the stop clock, at that time your time is 0 seconds. Okay, suppose after 1 second the car is maybe comes here. Okay, so this is the car. So after 1 second, so means so from the time you can tell the position of the car is changes here from one point to another point. So here you can see the change in the position of the car with respect to time. Suppose if there is no provision for this car passenger to look outside, if another passenger is there here, so suppose this driver has a provision to look outside, but these two passengers are not having the provision to look outside. So at that time, according to one passenger, he will tell the car is at rest because the another side, these doors, and if you look the another passenger or the driver, they are stationary. So another passenger is also telling that this passenger is stationary. But if they are looking tree outside by this tree and all, they will come to know they are moving. If there is no provision to look outside, at that time they may think that they are at rest. So therefore, to define the position, we need some frame of reference. So if we have one tree here, at the time we can tell this car is moving. If these passengers are not having the provision to look outside, at that time they may tell we are at rest. So therefore, to define the rest and motion of the object, we have to define position with respect to frame of reference, and another one is time. So therefore, these are the two factors. First one is some frame of reference is needed to tell the object is moving from one place to another place. We need some reference frame with respect to which we can define the position, and another one is time. So at what time, what is the position? Next what time, what is the position of the object? So therefore, rest or motion of the object is defined like this. When the body does not changes, its position with respect to time, then it is said to be at rest. So what is motion? When the body changes its position with respect to time. Now we completely understood what is the definition of mechanics. Mechanics is the branch of the physics which deals with the bodies or the objects or the particles that are at rest or in motion. So now let us move to the different branches of the mechanics. So now mechanics can be divided into two branches. That is, first one is dynamics and second one is statics. Okay, first we can discuss about the statics, then we can move on dynamics. So statics, as the name as itself suggests, statics means stationary or stagnant. Okay, so this is the branch of mechanics which deals with the stationary or the stagnant bodies, means the bodies which are at rest, that is we are studying under the branch of mechanics, that is called statics. So if I ask one question here, what is the cause for the body to be at rest? At the time, what is your answer? You may tell the cause for the body at rest is force is 0. Means if there is no force, you may think that the body is at rest. Suppose I can consider one case here, tug of war. All of the people you know. Here one person is there, here one person is there. Both are having the same strength. If he is pulling this rope in this direction and this person is also pulling the rope in this direction, at that time the position of this rope is not changes with the time. At that time t equal to 1 second, or if t is equal to 2 seconds, or if you consider any time, at that time you are getting the same position for this rope. So means we can modify your definition that when the body is in equilibrium with the different forces, at that time we are getting the body is at rest. Because when we are on the earth, so here we are having the gravitational force, that is the one force which is always acting on the body. When you are standing on the earth, here towards the earth you are getting the gravitational force, but opposite direction you are having normal force. The type of the forces and all you are discussing later. So the magnitude of this normal force and this gravitational force both are equal. So equilibrium of the force, at the time you will be at rest. So net force on the body is equal to 0. If you are in equilibrium, at the time net force on you is 0. Therefore the body is at rest. Now let us come to the another branch of the mechanics, that is dynamics. So we know the statics is deals with the stationary bodies, dynamics is deals with the body at motion. This is the branch of mechanics which deals with the motion of bodies. Okay. Dynamics can be further simplified into two branches, that is kinetics and kinematics. As we already know, there are different types of the motions, so we need to know what are the types of motion. Okay, for example, if you consider a simple pendulum that will oscillates, so it goes like this and come back. This kind of the motion is called vibrational motion or oscillatory motion. Okay, so next, leave the object in a slider, so it is moving in a one direction, that is the motion in a straight line. So that is called translational motion. Okay, so any object which is moves in a straight line, so that is called translational motion. So another one is a rotational motion. If you consider the fan, it happens, so it will rotates like this, right? So therefore this kind of the motion, so in which the body rotates about its axis, so this kind of the motion is called rotational motion. Types again in kinematics, that is translational, rotational and vibrational. These are the type of motion that we are studying in kinematics. So in kinetics we are dealing with what is the cause for this translational motion, what is the cause for this rotational motion, what is the cause for this vibrational motion. That and all we are studying under the branch of kinetics. Okay, so therefore here in dynamics we are studying what the types of motion as well as the cause of motion. If you are come to the statics, here also we are studying the body is at rest and what is the cause for the body is at rest. That is, what are the forces acting on the body to make it stationary or to keep the body at rest. So that and all we are studying under the branch of statics. Now let us consider the translational motion in detail. Okay, as I already told, the translational motion is nothing but the objects usually moving in a straight line. The straight line motion is called translational motion. Okay, for example, if you are having the slider, so if you are going to the beach, we are having the straight sliders like this. So if we are having one person or one kid who are going to slide like this, at the time he is going in one direction. Okay, so to define this one we need only one line, or this direction is enough to define the motion of this object or here this kid. Therefore the translational motion is defined as what? The motion of the object in a straight line. The bodies which moves in a straight line, then it is called translational motion. So if we are considering the coordinate axis, we are having the three coordinate system. That is, first one is x-axis, another one is y-axis, another one is z-axis. If the body is moving in this direction, so only one axis is enough to define that motion. That is called one-dimensional translational motion. One-dimensional translational motion. Suppose the body is moves in y-axis, there also we need only one axis. If the body is moves in z-axis, then also we need only one axis to define the body and its motion. So therefore the one-dimensional translation motion is the motion of the body which only needs one axis to specify its motion. Okay, so therefore we can define the one-dimensional motion like this: during the motion of the body, during the motion of the body, during the motion of the body, only one of coordinate specifying the position of the object changes with respect to time. Okay, if you are considering the time factor, if the position of this object is changes with respect to time in only one direction, so at that time we are telling it as one dimensional motion. Suppose if you are making any objects to fall from the tall building or anywhere, so suppose you are standing on the tall building and you are leaving any piece of paper, at that time if there is no airflow or any air disturbances are there, at that time your object is moves straight away down. Okay, so this kind of the motion is called one dimensional motion, translational motion, because it needs only one axis to define the object's motion. So next, similarly we can go to the two dimensional translational motion. Okay, two dimensional translational motion. So for that you can easily write its definition. So only the thing we have to change here out, during the motion of the object or the body, only two coordinates are specifying the position of the object changes with respect to time. Okay. Okay. During the motion of the body, only two of coordinates specifying. Therefore, two-dimensional motion of the body can be defined as the motion which requires two coordinates to specify the position of an object with respect to the time. So for example, if we consider the ant which is moving in this plane, when we leave the ant to move in this plane of the paper, at that time it will take a random path. But to define the motion of this ant, we need the two coordinate system, that is, first one is x-axis and another one is y-axis. But here the ant moves in a random path. Okay, so suppose the ant is moving in this random path, but this motion is also called the translational motion. Why it is so? Let's see. So if we zoom this path of the ant, here we are getting a straight line. Suppose we can zoom this part, again we are getting a straight line. Suppose we zoom this, again we are getting a straight line. So the each and every part of this one appears like a straight line if you see by microscope. Imagine you are an ant. At the time you can visualize only a small path, so that appears to be a straight line for the ant. Okay, so therefore this is also comes under the translational motion, but only the case is here we need two axes to define the position of the ant. Now let us consider one more example, that is boat. Suppose the water is not waving, so the boat is moving on the surface of the water, so it can't come up. So means only two-dimensional motion it is. So only x-axis and y-axis is enough to define the position of that boat with respect to the time. Therefore, the two-dimensional motion is that the boat also covers on the surface of the steady water. Okay. Now let us go to the three-dimensional translational motion. We can easily define it. The three-dimensional translational motion, in which the motion of the object is defined by the three coordinates, that is x-axis, y-axis and z-axis. So therefore it is defined as during which the motion of the body, during which we need all the three coordinate axes to specify the motion of the object with respect to the time. So for example, if we consider the paragliding in the sense, it is some of the people which are goes by a parachute like that. So in that case, the people are goes in a sky. So and they are covers a random path. Since the paragliding person is in the space, the position of this person with respect to time is changes in the space. So to define that position of that paraglider, we need three axes, that is x-axis, y-axis and z-axis. So therefore all the three coordinate planes is needed to define the position of the paraglider, so or any objects in the space. So if you are considering a cricket ball also, so if any batsman hits the ball, so at that time it jumps in random direction. So at that time, this also the case for the three-dimensional motion, because it moves in random direction. To define the position of the ball, so we need three axes. So therefore these are the three types of translational motion. So first one is one-dimensional, two-dimensional and three-dimensional motion. So let's recap all the concepts what we have learned today. First one, we have discussed about the mechanics. Next, we studied what is meant by the particle or object or the body. So next, we studied about the rest and motion of an object. Next one, we studied about the branches of mechanics and the types of translational motion. So hope you understood all this concept. So if you have any doubt, please comment. So see you next time.